This is a model that was built in the roof framing class we just had a couple of weekends ago. You'll notice that the hip doesn't bisect the corner at a 45-degree angle, as does a normal roof, but it's swung over. And so this is called an unequal intersecting pitch roof. This is the shallower pitch, and this is a steeper pitch, as you can see. So in plan view, with a standard roof, for jack rafters, the plate line from the side of the rafter to the inboard side of the short point would be equal to the run of the jack. But you can see, if you look down on it, this plate line dimension is longer than is the run. So how do we determine the run of these jack rafters if we had the 9/12, this is a 9/12 pitch and that's a 5/12 pitch on this side, the 9/12 pitch secant, the multiplier. All we need is the secant and the run, and we can find out the jack rafter length. So normally we pull from the corner to the short point on all of these, not the king common, but from this line where the hip runs through the plate, over the plate, that line, to the short point, each consecutive jack, and then multiply it by the secant. But in this case, like I said, this is longer than is that, and this run is different. And that's where the factors come in irregular roof framing, which we haven't talked that much about. This is the miter ruler, which you'll see on this YouTube channel a lot. And I can go over it again, but you'll see how it says the short side is 6.66 and the long side is 12. That's this hip, this triangle essentially in plan view. We have to establish that before we can find the secant of the hips. So the way you do that is divide the rises by each other. So 5 divided by 9 would give you this little short triangle, right? 5 divided by 9, or 9 to 90 degrees, 5, the hypotenuse, give you this little short triangle. 5 divided by 9 would be one of the factors, 0.555. You multiply it by 12 because we want the common rafter run, and that gives us 6.66. We draw that triangle out. Now we know how far the steep pitch travels for every 12 inches the common rafter travels. And we know how far the hip or valley travels on the level for every 12 inches that the common rafter runs on the level. So the common rafter runs on the level, and that's the shallow pitch, right? Because it's the longer one. The longer one's the shallow one. The steep has less to travel to reach the same rise as does the shallow. So this is the shallow one. So 12 inches is always going to be the shallow pitch, right? Anyway, the hypotenuse is the hip in plan view for every 12 inches that the shallow pitch common rafter runs on the level. And this secondary triangle is elevation. So this is plan, this is elevation. That's important to remember. This is going up. You know, elevation, you look from the side and you see height, elevation. Plan, you look down, straight down on it. This is elevation laid on its side, and with the shallow pitch rise. And the hypotenuse of that one is what the hip or valley travels on this roof for every 12 inches that the common rafter runs on the level, right? So every 12 inches, so if you divide that by 12, you get the secant. And the secant in this case is 1.217 times shallow pitch common rafter. Run gives you the hip or valley length. And this valley and this hip are the same length because they emanate from the same plate height and terminate at the same ridge height. So that we know. What we want to know is the jacks. Well, we went over the factors The factors are the sides divided by each other. So 5 divided by 9 and 9 divided by 5, which is the corresponding rises of this roof. And you write those numbers down because they're really important. These numbers you use over and over again. For example, we know this one is the run of the common rafter is shorter than is the plate line dimension. We want to know the run, so we take the plate line dimension and multiply it by the the smaller of the two factors, and that'll give you this run. This, because it's that triangle, right? Same triangle. 5, 9 reduced. So, anyway, and then multiply that by the 9, 12 pitch secant will give you the rafter length. You can pull from that point to the short point times 0.55, which is the factor, and then multiply it by the 9, 12 pitch secant, which is 1.25, 1 1/4, because 12 is 1 1/4 of 9, so it's 1 1/4, and that'll give you this jack rafter length, and so on and so forth. Now, when would you use the 1.8 factor? In what situation? Well, look at the other side. The other side is the opposite. The other side has a short plate line dimension, but a long rafter. So we take the plate line dimension on this side, multiply it by the bigger number, 1.8, and then that would be the run of this common rafter to the short point. You wanted to go to the long point, you go to the other side. Short point's on this side, so from where the hip runs through the plate line, right, lead edge to lead edge to lead edge of block, if there was one here, that triangle, times 1.8 would give the run, and then you'd multiply the run by the secant of this side, which is a 512, and the secant of a 512 is 1.083, written right there. 912 is 1.25, 512 is 1.083, right? And that'll give you the length of this one. How about with hips and valleys? Do you ever use these factors with hips and valleys? Well, let's take a look at these two hips here. Like I said, the run of these two hips is pretty simple. Span minus the ridge thickness divided in half gives us the run from the side of the rafter to the outside of the building, times the secant of the hip, which is, we said 1.217, will give you the rafter length from center line point to center line point, in this case here. In this case, it's from there to there, and then it would be to the outside of this notch here. You could do a nice notch here with a chisel and make it so that this was covered. We didn't. But what about this one? You see this run? Look how small this run is. This is the span minus the ridge thickness divided in half gives us the run from center line to the side of the ridge here. If we multiplied that run by 1.3, I say 1.201, or what is it? 1.217. It'd be one whole length of the run, and then 217, which would be about here. So that'd be how long it was. It wouldn't be long enough. It wouldn't reach way up there, right? It would swing and be at the same angle that this one is. These are at the same angle, but relative to the ridge, you see? The valley hasn't changed directions, but the ridge has. So this isn't going to be long enough. So what you do is you take the run, multiply it by the bigger factor, which is 1.8, and that'll give you a new run. Multiply it by the secant, which once again is 1.217, and that'll give the valley length. It's quite a bit longer, see? Now, since these are two different pitches, these ridges are, the peaks of these two ridges are different. This would be a steeper point, if you will. There's an imaginary point there, and this would be a shallower point, or vice versa, sorry. This would be a steeper point, this would be a shallower point. Mathematically, where they met would be the same, but since we didn't back these ridges, this ridge has to be a little lower to accommodate it. And this center line terminates into this ridge a little closer inboard, see? And then the rafter keeps going to meet it, the higher one, right? A little bit. So yeah, factors, after you determine what the rafter length, the secant is based on of the hip and valley based on your miter ruler, which is a combination of plan view and elevation view laid down on its side. 12 always being the shallow run, and the rise added to the shallow run is the shallow rise, right? In this case, it's 5 laid on its side. Draw a line and then divide it by 12. Figure out what the hypotenuse is 14.61 here, divided by 12 is 1.217. It's really basic. 5 divided by 9 times 12 is 6.66. Connect dots, a squared plus b squared, which is 5. We know what the hypotenuse is. A squared plus b squared, 6.66 plus 12. 6.66 squared plus 12 squared equals 13.73. Once you push the square root button, squared plus 5 squared equals 14.61. When you push the square root button, divided by 12 gives you 1.217. That's a lot of stuff, but if you do this with 5 or 6 different pitches, it'll become rote if you remember that this is plan view and this is elevation. That's dealt with. And then how do we get the factors again? 5 divided by 9 or 9 divided by 5. Or if you want, 6 divided by 6.66 divided by 12, 12 divided by 6.66, same numbers clearly, right? 0.55 and 1.8.